don't have pen and paper, or like don't use pen and paper, and are probably gonna write this out and then have to go find somewhere to print it, and would rather just turn it in like as a Canvas-y thing. Okay, how many people are cool with turning this in into print? Sick, we'll do that then. I made a Canvas-y thing just so that I can put the directions in writing up there, which I haven't done yet, but I will, I promise. And then that'll also have your due date on there so that the instructions and when it's due are not just stuck at the beginning of recordings in various places, YouTube channels and such. Okay, so, yes.
So how are we getting points back for the corrections? Is it like half credit for each question or full credit?
So, yeah, what we're gonna do is, however many, I'm gonna go question by question, and basically however many you missed on that question, you can earn back half of that for correcting that question. So it's gonna be, like, yeah, I'll just go through, like, each question and just figure out how many points each thing is worth. That means that if you got extra credit and also missed things, your extra credit doesn't count against you for how many, like, points back you can earn. So you can earn back half of what you lost, but not, like, the extra credit doesn't count against you, yeah? I'll, like, take that out and then tack it on at the end. You can't do corrections on extra credit. Yes?
Sorry, when you say half of what you lost, are you going like question by question? So if the question is worth 2 points and we get it completely right, when we correct it, we get 1 point back? Or is it?
If a question's worth 2 points and you got no points, and you got no partial credit on it, then you can get 1 point back for redoing it. If a question's worth 2 points and you already got 1 point partial credit, you can get half of whatever's left, so half a point back
Oh, I
for doing
understand.
it. Which sounds like it's not a ton, but I have like 7 and 9 point questions, so it's,
Yeah.
I feel like it's fine, yes. Don't write on your exam, write on separate pieces of paper. Staple the pieces of paper to the back of your exam when you turn it in, which I kind of messed up because I stapled your quizzes to your exam, but it's okay. They're the kind of staples that are easier to get out because they're the long staples. If you can't get them apart or can't turn that back into me, that's fine. It's not a huge deal. I spent all this time scanning them, so no worries. I have scans of all of them. Let's see. Yeah. And I've got a couple people who are taking a makeup exam. So preferably if your friend hasn't taken the exam yet, don't show them yours or tell them the questions. I'm making a different one for the makeup exam, but like, I really, really don't like most of the multiple choice questions in the test bank, and multiple choice are the hardest to make up off the top of your head, so I don't think I'm gonna reuse, but like on the off chance. Plus they're supposed to be similar anyway, so, you know. On that note, so test corrections are a thing. I'm not curving individual tests, and part of the reason I'm not doing that is, well, I'm not doing any specific like math on curving anything, and that's because I want you guys to be able to work together, and I don't want this class to be competitive. So I've just got the grades like separated out by percentage. But I might just sort of change the percentages. I'm never gonna change the percentages so it makes it harder to get a grade. You know what I mean? I might lower percentage, like, thresholds so that a lower percentage is a higher letter grade. Does that make sense? So I might do that at the end. I'm not 100% sure. I think so far it's gonna be fine, but like, I think it's gonna be fine. We might not have to do that, but I have that in the back of my head as a thing that we could do. Also, the percentages don't go to letter grades like most percentages go to letter grades. I have like I have a shifted scale already, so glance at that too if you're trying to convert your grade. All right, cool. Let's do some chemistry. How's it going so far? How's this class? Are we going at a reasonable-ish pace? I mean, reasonable for the fact that this is a 5-week class, and just inherently, I think that that's unreasonable for this class. We're all right? We're going decent pace for things? Okay, cool. Remember, I have office hours 1 to 2, Monday, Wednesday, Friday, and I'm usually around during TA office hours, Tuesday and Thursday after your rotation. So come hang out with me and we'll do homework parties or study parties or whatever. Yes?
I don't know if I missed it, but when did you say the test corrections are due?
Oh, next week, Wednesday in class. If you're gonna turn them in late, if you need longer, just let me know. Even if it's literally Wednesday in class, you're like, hey, don't post the key yet. Just let me know before I post the keys so that, preferably in person if it's last minute, just in case I miss the email. Yes?
Can we turn it in before then?
Yeah, sure. Yeah, that's fine. Okay. Is that all the business? I think that's all the business.
Quiz tomorrow got moved, right? It's next Tuesday.
No, not pushed back. There is a quiz tomorrow. The quiz the day before your final got moved.
Gotcha.
So I posted the lecture, I reposted the tentative lecture schedule, and stopped pretending that today we're gonna finish chapter 18 and start chapter 19. So I stopped pretending that, and I moved some quizzes. So you have a quiz, it's today Wednesday, you have a quiz tomorrow. Next week you've got a quiz Tuesday and Thursday. And the week after that, Monday is an exam, right? Yeah. Next week, there's no exams, there's 2 quizzes. The week after that, Monday's an exam, no quizzes, Friday's your final. And that's gonna be a quick turnaround on test corrections, but it's gonna be fine. I'll make exam 2's test corrections due like at the final exam, which won't be a bad thing because doing test corrections is going to be studying for your final because we agreed no note card, which means I will be stealing heavily from your exams for the final. But because we moved to the quizzes, that does mean that there will be content we covered the last week that I might have a couple questions on that will make it onto your final that you won't have had like a quiz on or something. So, yes. Yes.
Is there any way for our exam 2 that we could get our test corrections graded at least the day before our exam so we know if the corrections we made were correct?
Oh, yeah. Do you guys want
So I
them?
feel like that'd be better for
Do
study.
you guys want them due on Thursday before? Do you guys want to cross that bridge when we come to it? All right, fair. Good idea. Remind me later so we can.
Or like if it was optional for people that wanted to turn in their, I don't know.
Oh, yeah, yeah.
For me personally, I'd want to know the right answer before
Yeah, that's
I
fair.
take the final.
And if we make those due before the final, then if we make them due Thursday, then Thursday I can post the key to your quiz, to your exam too. You can use that to study too. That's probably a good idea. All right, so we are on hydrolysis of esters, and yesterday we hydrolyzed, before we hydrolyzed esters, we hydrolyzed acid chlorides and acid anhydrides. I wanted to say acetic anhydride, but that's a specific compound. Acid anhydrides, or anhydrides is the generic. So, with those two, remember, they are very reactive, so you can turn them into all sorts of things, and also if you get them anywhere near water or humidity, they are dead. And by dead, I mean, instead of Grignard reagent, dead, so they get protonated because they were base. In this case, dead is, they turn into carboxylic acids. So, remember this page. Technically, carboxylic acids aren't the lowest reactivity, but I mean, they're pretty far down there. Amides, yeah. Amides are less reactive than carboxylic acids, and then deprotonated carboxylic acids are, or carboxylates. Carboxylates are the least reactive. But still, these guys are reactive enough that if there's water around, you don't need any sort of acid or base catalyst. You can have whatever charges you want in that mechanism because it's aggressive and it doesn't want to be there anymore, and you get a carboxylic acid. Then we talked about esters. These guys are kind of on the same level. So in order to get this to go, you are going to need an acid or base catalyst. Yesterday we did acid catalyst, and we learned that, well, if you do acid catalyzed hydrolysis of an ester, it's literally step by step, like arrow by arrow, mechanism arrow by mechanism arrow, exactly the opposite of Fischer esterification, right? So now we're gonna do saponification, hydrolysis of an ester in aqueous base. And Fischer esterification has to be in acidic, right? Right? Yeah. Fischer esterification has to be in acidic solution. And I'm going to venture a suspicion that this might be why, but I'm not entirely sure because there are other things that can be acid and base catalyzed, so I don't know. But like a carboxylic acid, if you start with a carboxylic acid and you put it in basic solution, you'll deprotonate it, right? Have we had a mechanism? Did we have a mechanism in chapter 17 where we turned a carboxylic acid into something else in a basic environment? I don't think so. I'll check the things real quick, but I would suspect that's the reason that going from here to here, you have to use acid. Going from here to here, or no, going from here to here, you have to use acid because if you use base, you'll be down here. Starting here, you can go here or here. So you can do this in acid or base. All right. Sorry, I was stapling so fast and walking very quickly. With this, I misspoke. I said base catalyzed hydrolysis of an ester, didn't I? But this is hydrolysis of an ester in aqueous base. So before we had acid catalyzed, right? And we reformed our acid, so that was a catalyst. This time, we're going to use a mole of base for every mole of ester. So not catalysis, not just a little bit, enough to make sure that you got 1 mole for 1 mole, which in reality means not 1 mole to 1 mole. Throw in some extra because, well, base is cheap and probably not a ton of carbon, so probably not that difficult to separate on a column. So put an excess of something, put an excess of base. The thing, whatever has fewer carbons is going to be less of a pain on the column, basically. Okay, so let's It is going to look much the same, but like all, I want to say all, base environmental reactions, we've got fewer random proton transfers. I think, I'm pretty sure. Starting with, yeah, I'm gonna do, this one wants me to do, so on your notes that you're gonna get post-lecture, this one has CH2, CH3 here. One, that's more work to write and takes up more space, and horizontal space is, limited on this. And two, this is more useful, yes, we decided? So, it's specific on your notes, but it's okay. We've got this, and we have that. All right, so this is in base, which is why we've got OH minus, and it's in aqueous base, so we don't have to do any protonation first. We just go, hey, how about you get attacked? That's totally an arrow. Arrows gonna get smaller. I did it again. I'm too short for this. All right, cool. So we don't have a protonated, we've got basically a deprotonated alcohol and a normal alcohol. Both of those are fine to have in basic solution, right? Because alcohol is a pH of like 15-ish. So even if you make this solution really basic, like 14, you could expect an even amount of each of those to basically be present in equilibrium. So, all right. That is our tetrahedral carbonyl addition intermediate, right? We've got addition, but then, because we're no longer in chapter 16, we can do elimination. And if we can do addition and then elimination, we're doing substitution. Thank you. I was like, replacement, that's not the word. Substitution. See, sometimes it's to quiz you guys, and sometimes it's just, words are hard, so, Can I snake around this way again? Yeah? Somebody give me a head shake if you'd rather me really not. Okay, cool. All right, so now we are going to reform our double bond, because when in doubt, if you've got 4 things on a carbon, go ahead and reform your double bond. When you're doing mechanisms, remember that even if you don't draw out your carbon, you need to pay attention to how many things are bonded to your carbon. So if you don't actually draw it as a C, or you don't have all of your hydrogens on there, it might not be a bad idea to do something like okay, fine, I'm gonna do that. There. If we have something like this, it might not be a bad idea to just draw out where you actually have hydrogens, at least in the places that matter. And then if you start doing resonance or anything with any carbon that you haven't drawn out hydrogens for, go back and draw out all the hydrogens, because when you do resonance, you want to make sure that, and before you start doing resonance, it's not a bad idea to draw out lone pairs too. That way you can keep track. You know what you start with, right? Because We always start with 2 and 2, like all the time unless we've got a charge. And then that way we won't do like, different color. We won't do like that when we're trying to resonate, because that, if we have our lone pairs drawn out, then we know we've got 1, 2, 3, and we're taking away the 4th pair of electrons that this guy has. And this guy has 1, 2, 3, 4 already, and we're trying to add a 5th one, right? So we know that actually we have to go that way if we draw out these. Does that make sense? Does that help? Likewise, you're not going to go up. You're not going to break this double bond and just go up here for no reason. You're going to do that if you have something pointing like this to this bond, or something attacking the carbon trying to form a 5th bond. Yeah? Okay, cool. We can talk mechanisms at office hours if you want. Okay, so we're gonna reform this, but in order to do that, we've got to kick something off. If I kick this off, I've just done the backwards reaction, so yes, I can, well, actually, no, I can't really kick this off because it's not a leaving group. Even though this is totally, yeah, okay, fine. This is usually not a leaving group, but this is reversible, so whatever. In order to actually not just go backwards, we kick that off, yes? Now we have too many markers. That again, we have R, we have O, H. Yes, and then we've kicked off O, R prime, cool, there we go. This guy got a 3rd lone pair because we kicked it off. So we've got a deprotonated alcohol and a carboxylic acid. And what do we kind of want to do? Because right now, like, normally we're avoiding positive charges in basic solution and negative charges in acidic solution. And that's sort of a general rule for if you've got a basic pH, then if you've got an acidic hydrogen somewhere, especially like a hella acidic hydrogen, like that, right? Super acidic, because like, not, like, there's a charge, right? There's a positive charge and an electronegative ion, atom. You're gonna deprotonate those, right? So they wouldn't be there. In this case, we're in basic solution and we just made a carboxylic acid. Whose pKa is around?
4 to 5.
Yeah, 4 or 5. So, I mean, we might not be at pH like 15, where this deprotonated alcohol is in equilibrium. Well, it's going to be in equilibrium. We might not be at pH like 15-ish, where there's going to be as much deprotonated alcohol as there's protonated alcohol, right? But that totally isn't going to stay like that, right? Because we're definitely below pH, we're definitely more basic than a pH 7. If these guys are pH 4 or 5, well then let me write this so that we can do a step.